Okay, so I'm going to briefly talk about association rule. So the basic description is that association rules in data mining, right, are used to identify interesting relations between the different variables in a large database, not large databases, right? For example, right, I mean, the classical example of association rule is like, I mean, this is a very typical example, right? The classic example is discovery that people who buy the diapers, right, they often also buy a beer at the same time, right? Okay, so these rules can be help retailers and marketers make decisions about product placement, promotions and inventory management, right? For example, in the actually there's some notation that you should know. Notation is this arrow, right? So basically diapers, right? This arrow and beers, right? That means the diapers is antecedent and the beer is the consequence, right? And then, so this is a typical notations, right? They use arrow. And for the association rule, there are three key matrix. Starting from the support, and then confidence and the lift, right? The support, this measures how frequent this item appear in the data set, right? For example, rule A, arrow B is a support is the proportions of the transactions in the data that contain both A and B, right? And it gives the idea of how common the association is. So that's a support. And if you look at this equation for the support, they use frequently they use both notations, okay? A and B, or A arrow, right arrow, and B, right? I mean, these two notations are very common for this support. And then the equation is the number of transactions containing both A and B divided by total number of transactions. Okay, so that's the formula. And then confidence means that how often the antecedent and consequent occur together, right? And so this is like a kind of conditional probability, right? I mean, if you look at these equations, right, support A and B divided by support A. So given that A occurs, antecedents occurs, what is the likelihood of getting, like, what is the likelihood that event A and B occur together, right? So this is like conditional probability, right? That item B is present given that item A is present, right? Okay. So the high confidence indicates that the presence of the first item is a strong indicator of the presence of the second item. So that's a confidence. Lift is a little bit more complex than support and confidence. The support and confidence is kind of straightforward, but lift is that the lift measures the strength of the rule over the baseline likelihood of seeing the consequent in transactions given the antecedents. So if you look at this, it compares the frequency of A and B appearing together to what would be expected if A and B are statistically independent. Okay, so if you look at these equations, support A and B, right? This event that both A and B, occur, right? The support, and then divided by support A multiplied by support B, right? So this is like A and B are statistically independent, right? So this really implies that A and B are statistically independent. You divide it by this. So in case when you calculate the lift value, if the lift value is greater than 1, that means item A and B appear together more often than we would expect based on their individual support value alone, meaning that if they were statistically independent, right, indicating the positive associations. And lift is greater than 1, that means A and B appear together exactly as often as we would expect if they were independent, right? So basically there's no associations. So and then if it's less than 1, then means negative associations, okay? A and B appear together less often, than we would expect if they were statistically independent. So that's how you interpret this lift value. Okay. So the example, okay, the example is this. So let's say this is the item set, right? So let's say this is item set in both together. The first transactions, the customer bought coffee and the pastries. And the transaction 2 is in tea, coffee, tea, and this is like a very simple data set, right? As you can see, there's only 9 transactions. Okay, and then we can analyze this rule. For example, we can calculate the support for T, right? Among the 9 transactions, there are 5 transactions at T, right? For example, transaction 2, transaction 5, transaction 7, and etc., right? So if we calculate the support for the T, roughly what? 0.5, 0.55. And then the pastries, you can calculate the support value. And then it's 0.556, same thing. Okay. And then support tea and pastries together. So there are 9 transactions total, and there are 3 transactions where tea and pastry, they both together, right? So how many of them? There's about 3 transactions. So you divide it by 9, which is total transactions, and this is your support value, right? So typically the calculating support is very straightforward. And then calculating the confidence, let's look at the equation for the confidence is support A and B divided by the support A, right? So in this case, T is antecedent, pastry is consequent. So out of transactions that containing the T, right, 3 contains the pastries, right? So okay, so the confidence value, right? The way you can calculate confidence value is that you support T and pastries, right? T and pastries, right? T and pastries divided by support A, divided by support T, and then you can get what? You can get 0.6. Okay, so that's the confidence value. So this means 60% of the transactions that include T also include the pastries. Okay, so it's given, right? Given that support for the T, right? That should be the denominator, right? So that's the basically, yeah. So this confidence means 60% transaction that include a T is also include the pastry. So given T, right? So including T. So this transaction is basically the support A, right? Support antecedent, right? So basically that's the 0.6 is your value for the confidence. And the lift, right? Lift for the T, lift for this value, right? T being antecedents and the pastries being consequent, right? If you calculate the lift value, look at this equation. Support A and B divided by support A multiplied by support B, right? So the support A and B, that's a 0.3330, right? Because you already calculate this value, right? Support. And then divided by 0.556 multiply 0.556. So this first value, which is a support T, right? You have a support T. And then support pastry is 0.556 as well, right? So that's by, support T multiplied by support pastry, right? But you have to divide, you calculate this value should divide 0.3330. Thus, the answer is 1.08, right? So this means what? It's greater than 1, right? This means, since it's greater than 1, it's a positive associations. So lift value greater than 1 indicates that tea and pastries are more likely to be both together than expected if they were independent, right? So that's the key. Okay, so I just give you the short example, right? example with a very simple data set, right? And so I calculate the support and the confidence and lift values, right? Okay. And in my next lecture, I'm going to implement, right, this idea, right, this association rule using Python, right, using the Google Colab, and I'll show you the Python implementations. Okay, thank you.